All right, the lecture has been recorded. Just about 15 minutes late. Okay. All right, so let's do example one together. All right, example one. Given the graph of fx, can you find the following limits? All right, let's do it. So the first one, I want you to do, hey, limit when x approach 1 from the left. So you look at x equal to 1 here, right? This is x equal to 1. And then from the left, what is the limit here? So type in the chat, what is your answer? Super easy. Someone type in Thai. Okay, 4. Yes, everyone got 4. All right, next one from the right. -2. All right, easy, easy. A piece of cake for you. And then x approach 1. What is the limit when x approach 1? Fx. All right, some of you said D and E. Good. This does not exist. All right. Now let's look at 0. Right. Oh no, not 0, 6. Number 6. All right. So when x approach 6 here, so from the left you get 5. From the right you get, from the right limit, from the right you get 5. Everyone gets 5. Okay, good. Okay, good, good, good. The same answer. Why everyone keep typing this number 5? Okay. And the last one, yeah, because the left hand limit and the right hand limit, they are equal to each other, so we're gonna say this is 5. All right, sounds good. So calculus is easy, huh? This is now too hard for freshman student, but for those of you who already passed Olympic thing, you know how to prove something in math, and you want to learn this thing, you can email me for an appointment later so we can discuss this thing later. Well, it will take more than 2 or 3 hours to talk about precise definition of limit. But keep in mind that if you see this thing on online or on any book, this topic is not covered for our class. All right, so that is the precise definition of limit. So skip that. Well, but this is a real definition of limit. Well, for those of you who are interested, maybe you switch to, take a math minor, maybe. All right, next. So we're gonna look at something more interesting. So the real thing gonna start from now. So now we're gonna look at limit laws. So what you see here on the slide, number 1, 2, 3, 4, 5, 6, 7, 8. 7, 8, this thing, you can use it to help you to compute the limit. So the limit of summation, this is summation of limit. The limit of constant times the function, you can pull out your constant. Limit of the product, this is the product of limit. Limit of the quotient, this is the quotient of limit. However, the denominator cannot be 0. And then also if you see the something raised to the n power, so you can move n to to the bracket outside. And then also if you see the n root, you can do the same thing. Well, you can use anything, whatever you want. And also the basic thing that you need to know is when you see limit of constant, this is just that constant because it is just a constant function. So it doesn't matter where x approach to. So limit of constant is constant, and limit of x when x approach a is L. Oh, sorry, limit of x when x approach a is a, because this is a function y equal to x, right? If you look at limit of x when x approach a, so this is the same thing as you ask that, hey, what if I have the function fx equal to x, right, which is the identity function, and if you want the limit at a, right, the y value gonna be a too. So well, limit this thing is a. All right. This is how you figure out limit laws. All right, so let's look at the real example. All right, I told you this lecture going to be easy for today, so just stay with me. All right, example 2. So I want you to evaluate this limit. So I have limit of 3x plus square root x minus 5 over x plus 1 when x goes to 4. So first of all, so everyone take a look. First of all, I am going to show you how to do this thing in full. So if you want to use limit law, this is what you have to do. Well, I just copy the question first. I copy the question. And then after that, I'm going to use limit law. So I'm going to move limit to the top. And then over limit to the bottom thing, x plus 4. And then I'm going to use that the limit of the summation is a summation of limit. So this is going to be limit of 3x when x go to 4 plus limit square root x when x go to 4 plus, oh no, might be minus limit of x go to 4 of 5, then over limit. I know it's pretty annoying that you have to write this thing plus limit for x go to 4, but I'm going to show you how to do this in full first, and then after that you can pull out your constant. So this is that, and then you can pull out your square root. You have that, and then you can this is already good, so 5, and then on the bottom you have something that already good. Oh, this is 1, sorry 1 plus limit 1. All right, and then after that, now you can evaluate now 3, and then limit of x when x go to 4 is 4, and then plus square root 4 minus 5 because that is a constant 5, and then over 4 plus 1. So this is going to be 12 plus 2 minus 5 over 5, which is 9 over 5, right? 14 minus 5 is 9. Okay, good. So this is the answer. So this is actually the complete solution. However, you can see that ridiculous, right? Every time if we have to do something like this all the time, it's gonna be time consuming because this part that I box in green, this is just the way that we use limit law, right? We just use limit law that we just learned before that. Hey, we just use limit law to expand this thing, and at the end we're gonna get this thing, right? So for this class, it is acceptable to skip all the details I box in green. So for this class, you are allowed to start from the question and then move to this, the last line without showing anything in the box in green. But you have to keep in mind that you can do that because you use limit law. This is not because some of you are gonna say that, hey, when you see limit and then you're gonna plug in number 4 into the function and then that's it. So that is a quick way to do, but it is not correct in terms of mathematics. We did not plug in number 4. What we did is just we use the limit laws. but we just ignore 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 the way that we show the work here. So some of you asked in the chat now, for homework, do we need to write something in the green box? The answer is no, you don't need to. In the homework, you can start from this and then go to this acceptable. You get full credit. Does it make sense? So you can skip the thing in the box for homework, for exam, and for everything. So we trust you that you understand that this is done by using limit laws. But when you grow up, don't teach the kids that, hey, this is because you plug in the number x equal to 4. It is wrong if you say that thing. It is not because you plug in x equal to 4. It is because you use the limit law. But we just make the thing make the notation to be handy and compact. So we just skip some step. So from now on, I'm not going to show you the box in green now. So from now on, I'm gonna just use the bypass thing. So I'm gonna just start from the one that I highlight in yellow, and then that's all. I'm not going to show you the limit laws. So let's do another example. All right, example 3. All right, so let's look at the function fx equal to x cubed minus 2x plus 5 when absolute x less than or equal to 2, and x plus 7 over x minus 1 when absolute x is bigger than 2. So find the limit of fx when x approach 2 and when x approach negative 2 if exists. If it does not exist, explain why. You know what? The thing that we love to ask you on the exam is absolute value. So if you know that you are weak in absolute value, this is a good time to practice. So this is the easy one. So you can see that when you see x less than or equal to 2 here, this means x is between negative 2 and 2. When I say x, absolute x greater than 2 here, this means x greater than 2 or x less than or equal to negative 2. This is the way we just, the way we just take absolute value of, oh, sorry, not less than or equal to, just less than 2. All right, because the equal sign is with the yellow one already. All right, so that is how we get rid of the absolute value. And then now let's look at the limit of f when x approach 2. So to figure out this thing, what you need to do is you need to look at the left hand limit, right, and the right hand limit, because limit, the left hand limit and the right hand limit could be different, and that will give you a problem if they are different. So I'm gonna say at for x approach to from the left. So what I did is I am going to replace the function that I use. So when x approach to from the left, that means x less than 2. The function that we're going to use is going to be the function that I highlight in yellow. Because when x approach to from the left, x gonna be get closer to like 1.99, 1.999, 1.99999, 1.99999, right? That means your function is going to be the function that I highlight in yellow. So this is going to be x cubed minus 2x plus 5. And by using the limit law, you didn't plug in x equal to 2, but by using the limit law, you get 2 cubed minus 2 times 2 plus 5. The final answer gonna be the same thing as you plug in, but what you use limit law. You didn't plug in number. Well, but we just wave our hand that, hey, you don't need to show that thing. Just say it. This is good. And then this is 8 minus 4 plus 5, which is 9. Well, if I miscalculate, you can stop me because, well, sometimes I am too excited and then I miscalculate easy thing. So now let's look at the right hand limit. So this is going to be this function, right? For the right hand limit, you need to use the function that I highlight in orange, because, well, when x bigger than 2, we use the orange function. And then this is 2 plus 7 over 2 plus minus 1, which is 9 over 2 minus 1, which is 9 over 1. All right, which is 9. All right, sounds good. So this and this, they are equal to each other, right? So this is how we conclude. So we conclude that the limit of fx when x go to 2, this is equal to 9, because 1 and 2, this is 1, this is 2. All right, I'm just lazy. All right, so that is how you conclude it. Well, you can say 1 equal to 2, that's fine. All right, and then if you look at limit of fx when x approach negative 2, when x approach negative 2. All right, so let's look at that. Well, I'm gonna go a lot faster in the last 20 minutes because seems like all of you can follow this thing easily. So from negative from the left, well, you have to use the orange function, right? Because this is coming to negative 2 from the left. And then this is negative 2 plus 7 over negative 2 minus 1, which is negative 5 over negative 3. All right, which is, well, negative 5/3. All right, good. And then limit of fx when x approach negative 2 from the right, this is going to be tick tock, it's going to be limit of x goes to negative 2 from the right, x cubed minus 2x plus 5, and that is negative 2 cubed minus 2 negative 2 plus 5. This is negative 8 plus 4 plus 5, which is 1. Hey, and they are not equal to each other. So this means limits of fx when x approach negative 2 does not exist. Right? Because they are not equal to each other. Negative 5/3 is not equal to 1. All right. Something like that. Well, this is how we conclude two-sided limit by using left limit and right limit. Any questions so far? This is supposed to be easy question. Well, the exam going to be a lot harder. I mean, not a lot harder. Harder than this, but not completely hard. All right, so let's move to another example if you don't have any question. As I told you, if you have any question, you can leave the question in the comment. Well, this is also easy. Well, sometimes you need to factoring. Sometimes you need to factoring, because when you see this thing, you can see that, hey, I can factor x squared minus 1, right? And then I can factor x squared minus 3x minus 4. Factoring is a basic technique that everyone should be able to do it. So for those of you who cannot remember, so we have x minus a times x plus a. This thing gonna be x squared minus a squared. Everyone should know how to factor this thing. And, well, also x plus y squared. This is x squared plus 2xy plus y squared. And if you have negative side here, it's going to be negative side in the middle. So everyone should know how to use the factoring here. So we're gonna practice how to compute this limit. So you can see that, hey, first of all, let's try to use limit law. So what if I use limit law here? So if I use limit law here, so I'm gonna say, hey, x go to -1, right? And then if x go to -1, so I have -1 square minus 1, -1 square minus 3 times -1 minus 4. Hey, on the top I get 1 minus 1, oops, 0. Right? -1 squared is 1, and then -3 times -1 is 3. All right, and then, all right, that is 0 over 0. Hey, yay, this is 0 over 0. Can you answer this is a real number? The answer is no. So every time you get 0 over 0 in calculus, this is called indeterminate form. What does it mean by indeterminate form? Indeterminate form is the one that you don't know the value yet until you simplify more or you use other techniques. That is what does it mean by indeterminate form. So 0 over 0 can be 1. 0 over 0 can be 2. 0 over 0 can be 1.5. 0 over 0 can be log 2, can be any number. So we don't know yet. 0 over 0 is the thing that we call indeterminate form. Because 0 over 0, the answer is going to be the number that multiplies 0 and then you get 0, which can be anything. Right? So, hey, so this is indeterminate form. So every time when you trying to use limit law or plugging in, I mean, in your sense, so, and then you get 0 over 0, so you have to use other technique. And the first technique that we're going to use is going to be factoring. All right, so for this question, it is easy to factoring because, well, on the top, you can factor x squared plus 1, sorry, x squared minus 1 to x minus 1 and x plus 1, all right? And then on the bottom, well, how to factor this thing? This is x minus 1. No, x minus 4 and x plus 1, right? So that is how you factor it because you're going to get x squared minus 3x minus 4. And then this thing cancel. Sounds good. And then what you have left is limit of x go to -1. Limit of x minus 1 over x minus 4 when x go to -1. And that thing is -1 minus 1, -1 minus 4. This is -2 over -5, which is 2/5. This is your final answer. Done, right? Not hard at all, right? All right. So example 5. Well, we could do maybe 1 or 2 more example, then we're gonna stop. Yeah, let's do 2 more example, or maybe 1, and then we're gonna stop. Let's see. All right, maybe just 1 for example 5. All right, so let's climb up to another level of limit question. So let's look at the one with absolute value. So limit when x go to 3 of absolute of x squared minus x minus 6 over x minus 3. Find this limit if it exists. If it does not exist, explain. Well, the key thing is that every time you see absolute value, try to get rid of absolute value first. This is the hint. Every time you see the question about absolute value, it is a good idea that you remove the absolute value. So for here, you can see that if you do x squared minus x minus 6, this is going to be x squared minus x minus 6 or negative x squared minus x minus 6 depends on the value x squared minus x minus 6. If this thing is bigger than or equal to 0, then this thing is the same thing, right? If x squared minus x minus 6 less than 0, you have to attach your negative sign, right? Because if you remember what we learned when we are kids, it's absolute value of the triangle. This is going to be the triangle. If triangle greater than 0, greater than or equal to 0, it's going to be negative triangle. If triangle less than 0, this is what we learned when we were, young. So like suppose that I want absolute of negative 3. So this is going to be negative 3, and then I add one more negative value here, so I get 3. So every time when you have something inside absolute value, you just need to separate into two cases. Depends on that thing is positive or negative. So the same thing with this one. And then, well, I see this thing which is x squared minus x minus 6, and then I want to factor so bad because this looks good to factor, right? Because if you factor, you shall see x minus 3. So we're going to factor this thing. So to x minus 3 and x plus 2. Right? Because we can factor it. Why not? And then if x minus 3, x plus 2 greater than or equal to 0. If x minus 3, x plus 2 greater less than 0. And then what is the value of limit now? So you have to look at limit of x approach 3. Let's start from the left hand limit. All right, we're gonna do two-sided limit. So the key point here is every time when you see absolute value, try to use the technique that you learn for the left hand and right hand limit first. That is my my suggestion. And then you can see that, hey, when x approach 3 from the left, what does it mean? X gonna be 2.99, 2.999, 2.9999999. So what case that we're gonna have? Is it going to be the green one or the blue one? What do you think? When x approach 3 from the left, like 2.9999999, right? You can try to plug in the number 2.9999999 into the green one and the blue one that I highlight. Which one is correct? That one is the one that you have to use it. So you can see that the one that I have to use is the one that I highlight in blue. So this is going to be limit x go to 3 from the left. So I get rid of absolute value, so I have negative this. Why is that? Well, some of you can solve the inequality. If you can solve the inequality, that is good. So this thing is negative 2 and 3. This thing is negative 2 and 3. So the case for the green function is plus minus plus, right? So, well, this is a technique that, well, some high school, well, you can learn from some high school, but not every high school. So we see greater than or equal sign. So it's going to be something below negative 2 or something above 3. So for the same thing, plus minus plus. So for the case that I highlight in light blue is going to be this case when x is in between negative 2 and 3. So that's mean when x approach 3 from the left, you're gonna use the function that I highlight in blue. And that means I use this function and this gonna cancel out. And what you have left is limit of negative x plus 2 when x goes to 3 from the left. And that is negative 3 plus 2, which is negative 5. Well, we're gonna compute limit when x go to 3 from the right. So in case that x go to 3 from the right, so this is going to be limit of, this time I'm going to use the green function, right? So it's going to be x minus 3 times x plus 2 over x minus 3. And then this going to cancel out x plus 3. So you have only x goes to 3 from the right, and then x plus 2, and then that will give you 3 plus 2, which is 5. Because the left hand limit and the right hand limit are not equal to each other, we conclude that the limit does not exist. So I'm lazy, so I'm just say that thing. Done for this question. Well, that is the technique that we deal with absolute value. Sounds good? Any questions so far? All right, we have done 5 examples today. So this is example 5, example 4, example 3. And yes, I am going to post my annotated lecture note here on Blackboard later today. So for those of you who missed this thing, you can jot down later. All right, any question from students? All right. So if not, let me stop the lecture here.